Hi everyone, I am Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we have gathered to discuss the topic multivibrators from the subject linear integrated circuits. So this is the outline of this video, which starts with why do we need the pulse waveforms and what is multivibrator, types of multivibrator, comparison of multivibrator, and we are ending with the practical applications. So why do we need the pulse waveforms? Uh, Today's world, every digital systems like computers, digital watches, microcontrollers, everything need the pulse waveform, not the smooth waveform like sine waveform. So timing and switching signals are very important here. That is when we need to switch on the signal and switch off the signal, and we need that is digital systems need clock signals. So that is nothing but a continuous square waveform, and which is used for the control applications like controlling the motors and switching on switching off relays, switches, etc. So here coming to the engineering problem, so we need the circuit which provides the rectangular or square output with controlled on off timing and stable switching without any external input. So the circuit should act as the oscillator. So without any input it provides the output. So that is the necessary here. So that is possible with the help of this multivibrator. So multivibrator is a pulse generating circuit which uses the positive feedback. So it uses the feedback to provide the continuous output. So this provides by using the positive feedback which provides the square waveform as the output without giving any external input signal. So this is about the multivibrator, and coming to its classification, it is classified into astable multivibrator, monostable multivibrator, and bistable multivibrator. So we are starting with the astable multivibrator. So the name specifies, astable specifies there is no stable state in this type of circuit. So that which makes the output continuously switching between the on and off, that is high and lower state. Positive peak, the output will be switching between the positive peak and the negative peak value, so which shows the signal which provides or generates the signal as a square waveform. So that is your astable multivibrator, and the key parameters to note here is nothing but the frequency which specifies the switching speed and duty cycle. So coming to the monostable and bistable multivibrators, the monostable name specifies there is only one stable state, and bistable specifies there is two stable states. So when we are giving the trigger signal to the monostable multivibrator, so which makes the output to move from the stable state to the unstable state, and it will remains there constant for few seconds, and it will move to the stable state after the few seconds. So after giving the another trigger signal, it moves to the back to the unstable state and comes to the stable state. So this is the general functioning of the monostable multivibrator. And coming to the bistable multivibrator, which has the two stable state. So only by giving the trigger signal, it moves from one stable state to the another stable state. So this is the comparison of the multivibrators, and this is the riddle for activity. So I'm coming to the practical applications. So here the astable multivibrator is used mainly for clock signals and blinker circuits and flasher. Coming to the monostable circuit, which will be mainly used for timer circuits, and the bistable multivibrator will be used for the memory circuits like flip-flop and switches. So this is the time for summarization. So we have seen why we need the pulse waveforms, and what is the multivibrator, and what are the types of multivibrator, and what are the practical applications of the different types of the multivibrators. So this is the assessment questions, which starts with which multivibrator has no stable state. A stable multivibrator has the no stable state or zero stable state. And next question is, bistable multivibrator is mainly used as memory element like flip-flop. So this is the reference books and website link that we have used here. So that's all about this video. Thank you all for joining this video.